Have you ever been stuck at a party with horrible music? What about when that random person with no taste in music finds their way to the controls? We know. It's not a good time. This situation is called taking the aux, and it almost never ends as planned. Well, our device sets out to solve this issue with a fingerprint sensor that protects your personal music from other partygoers, as well as multiple inputs that simplify the controls on the playback device, just in case you don't have the time or energy to focus on your media at the time. There are many proposed solutions to this problem. However, they are often impractical or overcomplicated. Instead, we propose a simplistic and effective solution. We have designed a fingerprint-protected media controller that is able to control outgoing sound on a computer. You will be able to use your fingerprint to protect your music from being controlled by other people. Once your fingerprint is verified, you can use a combination of buttons and gestures to control the media. Then, you can relock your music by rescanning your fingerprint. In our last prototype, gesture controls and buttons were mainly featured. Now, the device utilizes an IR remote, gesture controls, and a joystick for input. Prioritizing a remote makes it more intuitive to utilize the device, almost like a TV remote. Our device's usability is second to none. With a variety of inputs, the user can select their desired method and continue to listen to music with no hassle. This makes the media controller perfect for people of all ages. Considering the functionality of the device, it's important to understand how it works. We used an Arduino Uno to receive these physical inputs and relay them to a Python program located on a Windows device. Inputs that are given by a distance sensor, buttons, and joystick provide all the user data from our device. Once sent to the computer, our Python program is where all the audio and system manipulation take place. Now let's take a quick look at the individual components that make up the device. Here we have the breadboard power supply, ultrasonic sensor, fingerprint scanner, breadboard, joystick, and LCD screen. As of right now, we have a final product that we would like to present. Since the premise of the project features the fingerprint sensor, we have run several tests to evaluate the accuracy and confidence of it. To test its effectiveness against strangers, 3 different people tried to unlock the device. Out of a combined 120 tries, the device falsely allowed access 0 times for a perfect score of 0%. On the other hand, for someone who has already scanned into the system, the device correctly unlocks about 80% of the time. The graph shown displays the range of confidence our device returned on these correct finger scans. Overall, the locked media controller utilizes a remarkable $12 fingerprint sensor that exceeds all expectations, perfectly executing its key purpose, keeping unwanted users out.